This is Björn Rüffer from the University of Newcastle in Australia. I'm going to talk about static assessment generation using Sagemath, which is a Python-based computer algebra system, and Decorators and Generators, which are both Python features. Okay, so Sagemath is like Mathematica or Maple, a computer algebra system, but it is free. It runs in your browser, and it uses these so-called Jupyter notebooks, which are effectively text files that contain your input code in cells and output, which is shown under these cells. I will use this to generate static output for assessment, static assessment items. So basically many different versions of questions that I can then use for various different further processing. And I don't really care for this presentation what exactly it is that this is going to. It's more about the process of generating these questions effectively. And I will talk about typesetting and previewing with LaTeX. This is really the main aim of this presentation. So let me just show you in 3 examples how the output, the end result can look like. Examples from my day-to-day assessments as a math educator. And then I will talk in a lot of depth, or at least a lot of length, maybe not depth, but length, about the workflow and some of these ingredients. So print output can look like this. So these are some multiple choice questions, and you see answers A, B, C, D, and then there's this always in the same location. The last one is always this option as a fail-safe. None of the others. Sometimes there's a mistake, right? And then you want some question that then catches the mistake, and you want that always to be there and always in the same spot. So that's that. The same questions could also appear in an online medium. So with the COVID-19 situation, the quizzes that were basically paper-based and looked like what you just saw had to move into the online world using Blackboard, which is a terrible product. But it has a feature where you can bulk upload question banks, basically, or pools as they call it, and creating these in Sagemath is a lot nicer than using, say, a spreadsheet software. So I'm not going to show a picture here, but there's also the option of generating just plain text files. I have a blind student, and if I want to let this blind student participate in assessment items, essentially like the other students, I can give the student a text file with LaTeX code embedded, and so basically the source of an assessment item, but slightly nicer, some structures removed, and that works like a charm. Now, let's come to the tutorial. I found this proverb here. I think this applies. I'm not really going to show you the finished, polished product that you can use for your own purposes. I'm going to teach you, I hope, how you can make your own that really fits your purposes. At least so far, the idea. Okay, and there are a few ingredients. First, I need to talk a bit about lists. So hopefully you know a little bit about lists in Python already. Then we will talk about LaTeX, and we will talk about, and specifically in this Sagemath Jupyter context and Python context, and then generators and decorators. So lists, here are some examples. I don't really want to go into that too deeply. This is very basic if you learn Python. Sagemath is built on top of Python, and the main thing is lists are the guys that are enclosed in brackets, and tuples are the ones in the round parentheses. And there's a display method that can display any Python object, whether it is a list of lists or anything else. It just shows it. And Python, these are not Python, Jupyter notebooks basically look like what you see here. You have an input field like this gray box, and then you have the output underneath. And the output is usually from the last command that you executed. Okay. Here's another thing. There's a set notation. And now let's come to generator expressions. So generator expressions are, for example, for loops embedded in a list. So what you have here is, well, it's basically like you read it in English. Your list consists of x squared for x in A, and A is this tuple here. So it's like set builder notation more or less, except that it produces a list. And yeah, so this is the set of, or the list of square numbers from 1 to 100. We can build in a similar, well, actually the first one is a generator expression, the next one is not. This is a list of tuples. The tuples are essentially question fragments and answer fragments. So I have a question prototype without all the fluff around it, and the correct answer without any fluff around it, and just a few pairs of those. And what I want is to typeset this nicely, and I can use these generator expressions. So again, this for loop, I'm iterating over these question fragments, and I'm iterating over pairs, and this is a Pythonic way here to deconstruct these pairs into separate variables, and then I can use these variables in what is called an f-string. An f-string is a formatted string, and it replaces things in these curly brackets, yeah, so that to generate this output down here, right? So that's what happens. So those are generator expressions. We can take this a step further. We can write a little function that shuffles the answers for us. First, actually, we need to get a set of all answers. Remember, our question fragments all have just a single answer. Here, I'm aggregating all the answers in a set notation, and I pick out just the answers from the question fragments. I will then pass the answers into this function that actually happens down here. So I'm defining the function here first, and then I'm applying the MCA function here to the set of answers and to 7, a specific answer. And what that does is the function, first it actually takes answers, which could be a list or tuple or set, makes it a set. That ensures every element is unique, appears only once. Then turn it into a list. Lists can be ordered, and in particular they can be shuffled. And then I take the first 4 elements of this now shuffled list of answers, and then I append another entry to my list, which is none of the others. Then I define within this function another function, which is called correct. And correct takes one argument, and if the argument equals this answer here, then it returns a star, and otherwise it returns a space. And I use that in this f-string here, which first has 2 spaces, then it prints correct of A. A stands for the current answer, and then another space, and then it produces A, B, C, D, E, basically, which is in the ASCII table, elements 65, 60, 66, and so on. I get these by converting this decimal number into a character in this replacement here. Then I have a closing parenthesis, that's this one. Then I have the actual answer, that's this one. And I'm iterating over I and A, and I get I and A. I is the current answer, and I get that from this enumerate function. What that does is it takes a list, in this case answers, and it returns tuples. And the tuples are the current position of the current answer and the answer itself. And then it looks like this. Now with that, I can put this all together and create a question database, let's call it that, which is just a list. And this list contains strings, and the strings have line breaks embedded in them. These are these /n characters in here. And if you print those, then it looks a bit nicer. Let's do that. So if you, actually this is not printed, this is just split. We can also split again long strings into lists. We will use that in a moment. Not so important right now. What is important is if you have a list of lists, this one here was a list of lists, You can use that, for example, to populate a table. This produces a table using pandas, which is just a very standard Python library. And so you have a table, and this table, pandas, has all these different export functions, and that allows you to save the table you have, called a data frame here, Python lingo, into a CSV format, comma-separated value format. That's fairly common. And you can use that to upload something into Blackboard, for example, which is my use case, this online teaching platform, which also offers assessments. And it has to be a TSV file, which is sort of the same as a CSV file, except that values are not separated by commas, they are separated by tabs. And this line here just outputs the contents of the file that I have just written with this command here. And this is what the file looks like. So it's very easy to dump a list of lists into a TSV file or CSV file or even an Excel file. And that's good to know. Now we can do some more exciting stuff. So you can generate, for example, a linear combination of monomials with random coefficients here. So that's a polynomial, and you can differentiate that if you want. So these are all built-in Python features, and we can typeset also in other longer expressions that might be hard-coded using HTML and possibly LaTeX. We can write a wrapper, which in this case is a class. I'm not going into the details here. But basically what's happening here is, depending on the context where this MathJax class is being used, it gets initialized with a string. It just stores the string, and if the context asks for a HTML representation, then it returns a string that first contains this JavaScript loading command here, and then the string. And if the context just asks for a plain string, it just produces actually the same expression, which could also just produce this one here, just the string itself. So that's just very briefly. How do you use that? You can use this to wrap a string. So here's a string, and we wrap this into this MathJax class. And now the display function requests a HTML representation out of its argument. So this one will return this HTML representation, which doesn't look very nice here in the presentation, but if I switch really quickly to the notebook, to the actual notebook, you see here this looks a lot nicer in the notebook, which is your development environment. Okay, you can also print the same wrapped content. So this is something that you might output into a file to be uploaded into Blackboard, because Blackboard doesn't deal natively with mathematics very nicely. It's all like 1969 basically, by the looks of it. So this one is then something that you could somehow recycle and upload, say, into your online teaching platform. Okay. That's how you can do that. We can also access the LaTeX representation of a Sage expression, and this is something that you can also further recycle. So this LaTeX command works universally within Sagemath. Now let's move to generators. You remember these generator expressions, and that's not what I mean. I mean these guys here. So range 10 produces the numbers from 0 to 9, right? Computer science. And we can use that for questions, for question generators specifically. So here's an example. You can think of this question generator like a function that you can call multiple times, and every time it produces or returns something else using this yield statement. So functions that we defined earlier had a return statement. The yield statement doesn't actually end the execution of the function. It just returns this value, and then the function internally continues, and then it produces the next thing to be processed by the parent code. And it's advisable to wrap whatever you do in these generators into a for loop with a finite and maybe not too large number of maximal iterations, because otherwise you might very easily end up in an infinite loop, and that's a bit disruptive. So advice against that, and just to always have something like this in your code. Maybe just put I don't know, 200 or something here. That seems to work nice. Okay, so if you call this generator function, what you get is a generator, which is maybe not surprising, but you may have expected actually a list of these guys here, right? Actually, this will be returned as a tuple. So how you use that is actually using this in keyword. So you say for q in this generator, and notice I call this function and it returns the generator. So it's like more or less like the range function, or range generator. And then I can just show this q thing, which might stand for a question. And that's how you can use that. Now let's also format these lists real quick, similar to what we did earlier. So here's just a little quick and dirty formatting of these questions. So this is how they look like as strings, and then we can also print them, and then they look really nice. Okay, so this is something that would make sense to see under the cell where you are developing your question generator. So let's put this into a function and use that later. So I'll just have this as my question printer, take a list of questions and produce nice output. Okay, so the details are not so important. We have basically done something similar previously. We only show the first two elements of the list that we're putting in here, by the way. Okay, with this, let's talk decorators. So imagine you're developing a new quiz question, and there might be multiple quiz questions, and the development of quiz questions, as we all know, is an error-prone process. So you would probably like to preview the quiz questions that you generate, because you also generate all these different versions, and of course you want to make sure that everything is nice and works okay, and so on. And so you might be writing this question generator to produce lists because they're so useful. And now you would like to preview the output. And this could look like so. All you have to add is with preview, or add with preview. And then you have the same development code, and you work on this on the cell in your notebook, and you keep changing this and re-executing the cell. And every time you get a new output sampled from this generator, previewing what you have just done and how that might look like. And that's really nice. Okay, this is something I actually use, and I have multiple of these depending on what I'm trying to do. This thing up there is called a decorator, and now of course you wonder, where do I get that from, or how does it work? So this is something you have to make yourself, but luckily it's easy. And all you really need to write is this short piece of code. So we already defined a function that does the pretty printing. That's this function here. And what we also have is the generator. That's this function here. And basically what this fancy notation here does is it is basically a function call. It calls the function with preview, and as argument it passes this function. And this function can be a generator, obviously. And the decoration step is that it takes the function and does something to it, and then returns the function, or the modified function. Or in our case, because we're dealing with generators, it takes an instance of this generator and then samples the first two elements of this generator that's happening here, and then just returns the original function unchanged. And that's the whole decorator. That's all it really is for previewing purposes. If you were to use this for also saving the question into a file, you would add the code also maybe right in here. And if you wonder what file name to choose, you can access the name of this function. So this name here, simply as in this function, in the decorator code here, as f.__name__. That gives you the name of the function, and then you can use that as a file name, for example, to create a file that is called quiz1 elementary products, and then maybe .txt, .tsv, .tech, or whatever. Okay, so I hope that suggests a good strategy for you there. Okay, that's basically all. Let's recap what we have looked at. I'm of the opinion that static assessment generators are extremely powerful, and lists are basically a universal format to store prototype questions in, and then you can later do more with them, or you just have the generator and store that, and you can create as many questions as you want, but then you can use these static questions and upload them, say, to Blackboard or Moodle or whatever you're using. So generators are really nice, and they should produce lists of question-answer pairs or question and then multiple choice tuples. I find it useful to always have the first, if you go for the second option here, question and then multiple choice tuples. My multiple choice questions always have 4 actual answers. The first one is always the correct one in the development code, and then the shuffling happens in these decorators and while the questions are being saved. And that makes things a little easier. And also in that code, this last option, none of the others is added. Okay, so that's something we use a lot, these multiple choice questions. All right, and then in your decorator, you can also then have this transformation code, and how you actually transform your lists into the format that you want is up to you, but there's a lot of features and libraries available in Python that can help you, like pandas is one, and you can feed this into LaTeX, for example. There's a thing called the EAMS package. There's also a software called Math4X that I developed a few years ago. It's a Ruby script that takes question banks and generates many different randomized versions of course, the randomized versions have to pre-exist in these question banks, but it creates a nicely typeset output for multiple workshops that run on a weekly basis. So because these workshops don't run at the same time, the versions all have to be different and so on and so forth. So that's something that's used a lot here in Newcastle. So, and a lot you can put into these decorators. The decorators are really the most recent find that I had that really changed my workflow, just developing these question generators and then decorating them, and the decorator, the choice of decorator, I have a few really changes then what the output format is and what happens with the questions being generated. So that's really a game changer for me, and I hope something similar perhaps in the future for you. And that's all. Thank you for your attention, and I'd like to close with showing you 2 links. I will have the slides for this presentation up here in the first link, and this Math4X software is available under this second link here. So maybe something useful for you. Thanks again.